Hello class, this is Mr. Hart, and in this podcast we're going to work with finding missing sides of right triangles. And in the last lesson we talked a lot about trig ratios, but we didn't really talk about why we needed them and what they're used for. We just learned how to identify them and set them up. But today it's going to be very clear why we need to have trig ratios and why they're super helpful for solving right triangles. Okay. So rather than describe the process of finding missing sides, let's just introduce a problem and see how we'd solve it. Okay. So let's say we have this right triangle right here. We're given an angle, we're given the length of the hypotenuse, and we want to find this side B. Okay. Now, you may be tempted to say, oh, we can just use the Pythagorean theorem. But we only have one side, right? We need to have two sides in order to use the Pythagorean theorem. So we only have one side, we can't use that, okay? But we do have this angle right here. So we need some way to connect angles to the side lengths, okay? And that's where trig ratios are going to come to play. Okay, so trig ratios are used to help us find these missing sides, okay? So for example, in this problem, if you look at the variable b and the hypotenuse, which is 5, they're related by the cosine ratio for this angle 51, right? Because the cosine of the angle is equal to adjacent over the hypotenuse, right? If you remember that from our last lesson, we had all those ratios that we want to memorize, okay? And that's the relationship for cosine, right? Cosine of the angle is adjacent over hypotenuse, okay? Well, in this case, the cosine of 51 degrees, which is this angle, okay, is going to be the variable b over 5, okay? Now, we have a very simple equation that we just need to solve. For solving for the variable b, all we got to do is just times 5 over to the other side. So we'll get 5 times the cosine of 51 degrees equals the variable b, okay? And there we go. That's all we got to do. So we pull out our calculator, okay? We use that cosine button, which you probably have never actually used on your calculator before. But there's usually a cosine button somewhere, okay? And what we want to do is just do 5 times cosine of 51 degrees, and you should get 3.71. But let's double check. Okay, if I do that again, 5 times cosine of 51, okay, then I get the correct answer, which is b equals 3.147, okay, or 466, okay? So let me show you this on my calculator so you can kind of see. Sorry, this is just on my phone. But if you notice, I put in the exact same calculation twice and got two different answers, okay? This is why this can be super tricky for this lesson, because some calculators default to what we call radians and some default to what we call degrees, okay? And so this is where a lot of students get confused, because they'll put in their answer and they'll get 3.71 because their calculator was in radians, not degrees, okay? All it is a difference between how you measure the angle. Are you measuring it in terms of pi, which is radians, or are you measuring it in degrees, like in this problem right here where it's in degrees, okay? So this is what I want you to do right now. Look at your calculator, whatever it is, if it's the TI-84, if it's your phone calculator, whatever it is, put in 5 times cosine of 51 degrees and make sure you get 3.147 or 466, okay? If you do not get that, your calculator is probably defaulting to radians, okay? So I'm going to show you what you do on a TI-84. What you're going to do is you're just going to click the mode button, okay, the mode button. Okay, so if you click on mode, okay, it pops up with this little menu right here, okay? And what you want to do is make sure that that third line, okay, third line right here, okay, you want to make sure degrees is highlighted, not radians. You want to make sure degrees is highlighted right there, okay? And so that's a huge key for this lesson, because I've taught this before and had, you know, tons of students getting wrong answers because they were typing it into their calculator with radians the whole time, okay? So that's how you do it on TI-84. Make sure it's in degrees. just check on your own calculator. There should be some type of button, sometimes some type of menu selection where you can change it from radians to degrees. Okay. And again, the calculators do this because 51 radians is different than 51 degrees. Okay, just again how you measure that angle. Make sure it's on degrees. Okay, before you get started. So just go ahead, type that in your calculator. Make sure 5 times cosine of 51 gives you 3.1466. Okay, or 3.147. Okay. If it doesn't, fix it before you try the rest of these problems. Okay? So, but the idea is simple, right? That's probably the biggest thing that happens on this homework is that students use the wrong calculator mode. Okay? But really simple otherwise, right? You just find an angle, you use the cosine button or whatever it is, right? Times it through, and that gives you your answer. So we could say that B is equal to 3.147. Okay. Then from there we could find this side by using the Pythagorean theorem, and we'd be set to go. Okay. All right, that's a point. All right, but anyways, that's how you do it, right? Fairly simple, right? We can use these angles, trig ratios, to find missing sides. Okay. Let's look at another problem. Okay, so in this case, we're trying to find this side right here, A. Okay, and so we were going to need to use a trig ratio. We only got one side length, so we can't use just a standard Pythagorean theorem. Okay, so let's set up our trig ratio. And if we recall, if we have an opposite side and an adjacent side, that's going to be tangent. Okay, so the tangent of the angle is equal to opposite over the adjacent. Okay, opposite over the adjacent. So in this case, we're going to get tangent of 43 degrees equals A over 7. Okay, so we times the 7 to that side. So we get 7 times tangent of 43 degrees equals A. And there we go. So we just pull out our calculators. Again, making sure it's in degrees, not radians. Okay. And we put in 7 times tangent of 43. Okay. If you do that and your calculator's in the right mode, you should get that the side A is equal to 6.527. Okay? Or sorry, 528 when you round. All right, there you go. So that's the side length, 6.528. Okay? That's what A is equal to over here. Okay, so very simple. Again, calculator is probably the biggest thing on this homework. Okay? All right. Let's look at another scenario. A little bit different. Okay? So now in this case, we got this angle right here. We're trying to find or trying to find the hypotenuse A, and we have this side length 5. Okay? So there's two different ways to do this problem. I don't care either way that you do. I'll show you the way that I like to do it and like to think about it. Okay? So I always like to do it so that it's the variable's always on top of the ratio, the trig ratio. Okay? So you could say that adjacent over hypotenuse is cosine, but if you remember, the reciprocal of that was hypotenuse over adjacent was the secant. Okay? So I'm going to write it this way. Your teacher may do it differently. They may do it in terms of cosine. This is how I like to think about it. Okay? So the secant of the angle is hypotenuse over adjacent, right? And in this case, we're going to get that the secant of 45 degrees equals A over 5. Okay? And the reason I like this is so it's easy just to times that 5 over. Okay, so 5 times the secant of 45 degrees equals A. Okay? So again, all we got to do is times that into our calculator, and we get the answer. But you'll probably notice you don't have a secant button on your calculator. Okay, I've never seen a secant button on the calculator. Okay, so this is how you type it in on the calculator. Okay, all you gotta do is do 1 over cosine of that angle, and that gives you the exact same thing. Let me rewrite this so it's a little clearer. So 1 over that cosine, okay, is the exact same as the secant of that angle. Okay. And again, that's why you can do it in terms of cosine initially, and you just get a slightly different way of looking at the problem. Okay, but either way, but 5 times secant of 45. So if we're putting this in our calculator, we're going to do 5 times 1 divided by the cosine of that angle. Okay, like that. Okay, so 5 times 1 over cosine of 45 is the same as timesing by secant of the angle. Okay, and that's true no matter if it's this problem or any time you're doing trig in any sense. Okay, secant's the same as 1 over cosine in your calculator. Okay, so we press enter on that, and we get that A is equal to 7.07. Okay, and there we go. So again, law of calculator tricks on this one. So remember to make sure your calculator's in degrees, and also remember that any trig ratio, any of the reciprocal ratios, cosecant, secant, cotangent, is just 1 over the regular ratio. So secant's 1 over cosine, cosecant's 1 over sine, cotangent's 1 over tangent. Okay, when you plug them into your calculator. So let's go ahead and try one more problem just to make sure we got this down. Go ahead and do this problem on your own, okay, just to make sure that you understand how to plug into your calculator and everything. Pause the podcast if you need to make sure you have time to do it, okay? But if you do it and you go through it, you should find that the easiest trig ratio to work with is either sine of the angle, or I'd like to think of it in terms of cosecant of the angle so that the A ends up on top, okay? So cosecant of the angle is going to be hypotenuse over opposite. And so that gives us cosecant of 58 degrees equals A over 8. So times the 8 over to the other side. 8 times cosecant of 58 degrees gives us A. Okay. So again, when we type that into our calculator, we just need to make sure that we do 1 over sine to give us cosecant. So 8 times 1 divided by sine. Okay. Like that, just to make sure we're understanding. That's how you put it in. And when you press enter, you should get that A equals 9.43. Okay. So there we go. That's how we use trig ratios to solve for sides of triangles. Okay. So it's pretty cool that we can use all these different parts of the right triangles to solve for other parts. Okay. And then again, if we understand how to make sure we put this right in our calculator, it's a fairly simple problem. Okay. But that's all for this podcast. Let me know if you have any questions, and thank you for watching.